All right, we're going to go on now to example number 3, which is an application problem of doing the square root property. So we have an expert marksman who can hold a silver dollar at his forehead. And then when he drops a coin, he can draw his gun and he can shoot the coin as it passes his waist level. Now, if the coin falls at about 4 feet, use the formula distance equals 16 times time squared. So d is our distance, t is our time. So d equals 16t squared to find the time that the elapses between the dropping of the coin and the shot. Okay, so we're given this formula right here. Distance equals 16 times t squared. And it says that if the coin falls at about 4 feet, well, our 4 feet would not be our time, but that would be our distance. Okay, so that means we would have 16t squared. That means I can replace my d with 4 feet. So we have 4 equals 16t squared. And that's why the question is find the time. And that's why we're going to be solving for t. And we just solve for t then. So if we want to solve for t, okay, we're not going to take the square root of both sides. We're first going to always get rid of our coefficient in front of our variable. So we can divide both sides by 16. All right. Now, don't make the mistake of saying that this is 4, okay, because 16 doesn't go into 4, but 4 goes into 16. So the way that you think about that is you say, oh, well, I can divide the top and bottom by a common number, and that common number is 4. I can divide the top by 4, and I can divide the bottom by 4. So 4 divided by 4 is 1. 16 divided by 4 is 4. So this whole thing is actually 1/4 equals t squared. All right, so I'm trying to solve for t. So now we're going to use our square root property. Now I'm going to take the square root of both sides. Okay, and we get plus or minus. The square root of 1 is 1. The square root of 4 is 2 equals time. Now, since this is a word problem that's supposed to give us a real life context here, let's think about this. Our time should always be positive, right? We never talk about negative time. There's no context for that in a real life situation. So actually, we're going to ignore the negative, and our actual answer is just going to be time equals 1/2 or 0.5. And this is going to be in seconds. And it's real important that when we do word problems that we put the unit of measure. It's 0.5 feet, 0.5 seconds. Just whatever we find, it should have some kind of real life context of unit of measure, you know. So again, we ignore the negative because time is always measured in positive numbers. We don't say, oh, negative 20 seconds, I will go to grandma's house. Like, what the heck does that mean? Right? I mean, time travel or something like that. I'm not sure. But all right, so this would be it right here.